In this video, I'll take you through how to set up and run Helios simulations on Linux platforms. And I'll do so using three different approaches. The first is using the CLion Interactive Development Environment, or IDE. This is the approach that I recommend and what I use myself. The CLion IDE has a lot of great features and makes setting up and running Helios simulations very easy. And although CLion is commercial software, the nice thing is that if you are in academia, then you can get a free educational license from JetBrains in order to use all of their tools for free. So I'll show how to do that a little bit later in the video. I'll also go through how to set up Visual Studio Code. If you're already using VS Code for other programming applications, then you might prefer to just continue using VS Code. It'll work just fine. It's just, in my opinion, a little bit more clunky than CLion and doesn't quite have as many features. Finally, I'll take you through how to use a command line interface. If you're a little bit old school and you like to program from the command line and use text editors like Vim or Emacs, then you might prefer this route, and so we'll go through how to set this up as well. We're going to go through each one of these methods independently, so if you already know which approach that you want to use, you can go ahead and fast forward to that part of the video. However, there are certain prerequisites or components that need to be done regardless of the method that you use. So you want to watch this part first, and then you can fast forward to the other part if you know which method you want to use. If you're not sure which method you want to use, then go ahead and watch all of them and you can kind of decide what suits you best. So first thing we're going to do is install the GNU C and C++ compilers, and then we'll install the CUDA toolkit. This is needed if you're using GPU plugins. If you're not using any GPU plugins, then you don't need to do this step. All right, here we have an Ubuntu desktop. This is a fresh install. Nothing has been installed on it so far. So let's go ahead and first install the GNU C++ compilers. So we can do this by opening up a terminal window. And then first, let's update our apt-get repository so that it can fetch the latest software. We can do we need to do sudo apt-get and update. It'll ask you to put in your password. All right, it looks like that was successful. So now let's go ahead and install the C++ compilers. So we can do sudo apt-get install, and then we'll install GCC. And go ahead and click yes to continue. It'll install a bunch of dependencies as well. All right, here it's looking to upgrade my kernel. Click OK to that. Okay, so let's type which GCC. It should give us a path to where it just installed the compiler. We can also type in GCC-version. Sorry, it's GCC-version. So here we're running GCC 11.4. All right, let's also install the C++ compiler. That just installed the C compiler. So we'll do sudo apt-get install G++. And yes again. Okay, so let's try which G++. So there it is, and we can do G++ --version. And we have the matching G++ compiler. So now we have our C++ compilers installed. Okay, the last thing that we need to install is CMake, which is for building projects. We can simply do sudo apt-get install CMake. And there we go. Okay, one more thing that we need to install are dependencies related to graphics or the visualizer. So if we want to do visualization within Helios on Linux, we need to install several different packages in order to be able to run X11 graphics. We can get the current packages that we need to install from the Helios documentation for the visualizer. So if you go to baileylab.ucdavis.edu/software/Helios, this is the Helios documentation. And we want to click on plugins and then find the visualizer, which should be the first entry here. And one of the first things that you see are the dependencies for the visualizer plugin. And so for Windows, we don't have to do anything. For Linux, we can just copy paste this command here into our terminal, and this should install everything that we need. And there we go. All those should have installed successfully. Before we install CUDA, there are just a few considerations we want to note before we get there. Mainly the CUDA version that we're going to install. And the CUDA version depends on the actual GPU hardware that you have. As NVIDIA has continually upgraded their hardware, they assign a numerical value called the compute capability that designates the actual computing generation of your GPU's hardware, and this increases with time. Helios supports GPUs with compute capability of 3.5 or greater. However, if your compute capability is 3.5 or less than 5, then you need to enable some special legacy options when you build Helios, and then you also are going to want to install CUDA version 10. NVIDIA came out with compute capability 5 quite a long time ago. I think it was around 2016 or 2017. So your GPU has to be pretty old in order for it not to work with just the latest CUDA version. But if it's really old, you might want to go ahead and check your compute capability. And there are two main ways that you can do that. If you've already installed the NVIDIA graphics drivers, then you should have this command called NVIDIA SMI. You can run this command and it will print what your compute capability is to the command line. But if you haven't already installed it and you're trying to figure out which version to install in the first place, then you can go to NVIDIA's website and they have a page where you can look up what your compute capability is, and I'll link that down in the description. Okay, the next thing that we want to do is to install the CUDA toolkit, and there are a number of ways to do this. You can do it using apt-get. I found that this can be unreliable. I found that just downloading it directly off of the CUDA website and then installing it from there tends to work pretty reliably. So that's the approach that we're going to use. I would also recommend to take a look at the CUDA install page following the link that you see on the screen. Okay, so let's open up our web browser and we'll go ahead and search for NVIDIA CUDA download. And here is the latest version, CUDA Toolkit 12.2. We can go ahead and install the latest version. Then it'll ask us our operating system. We're using Linux. Then it will ask your architecture. We'll select x86-64. Then it will ask about your distribution. This is Ubuntu. Then it's going to ask us what our Ubuntu version is. And mine is 22.04. And then it's going to ask you how you want to install either a deb file locally, so downloading everything first, doing a deb file from the network, or using a local run file. So we can do deb from the network. It tells us exactly what we need to run here. So this wget command is how you actually install it. We'll copy and paste that into our terminal window. And then we'll run this command here. All right, so that took quite a long time, but It looks like it has installed successfully. The last step that we need to do is to reboot your computer. So you can do that through the normal graphical approach, or you can do sudo reboot. All right, now we can go ahead and install our IDE. And again, the first method that we're going to use is using the CLion IDE, which is made by JetBrains. So first we're going to go to jetbrains.com and create an account. Then we're going to download and install the CLion IDE. From there, we can pull the Helios code directly from GitHub, and then we'll set up our toolchain as well as CMake in order to run a few Helios sample cases. All right, let's open up our web browser here. Now we can type in www.jetbrains.com. And here you'll find this little person icon. You can click on that and go ahead and create yourself an account. And you can create a free account that's a trial license that you can use, I think, for 30 days or something like that. So that'll be enough to get going. However, if you are in academia, I would recommend to get yourself a free education license. So if you come up here to the top bar, over to education, and then you'll find on the right free licenses. So you'll find one that says free students and teachers JetBrains IDE for individual academic use. We can click on that. And you can scroll down and find information about free educational licenses. So if you're a student or a teacher, then you can get a free educational license. You just have to verify your affiliation once per year. It will renew your license for free. So we can go ahead and click on this apply now if you want to get yourself a license. You'll notice that there are only two options here. There's either I'm a student or I'm a teacher. If you are a postdoc or a professional researcher, then there's no option specifically for you. However, I did get in contact with JetBrains to ask them about this question, and they basically told me that as long as you're using it for educational purposes and you're not, using it for commercial reasons, then you're okay if you're, say, a postdoc. You can go ahead and verify that with them if you're unsure, but they told me that postdocs should be okay. So you can go ahead and sign up for a free educational license, and then they'll get in contact with you so that you can activate that license. All right, next let's go ahead and download the CLion IDE. You can get to it by navigating through the JetBrains site, but I think it's easiest just to type in CLion download. It'll take you right to it. It should detect your operating system automatically, and then you can go ahead and download. Okay, once our download has finished, we can go ahead and open up that file. And I'm going to open it up in the File Explorer. And you'll notice that this is a zipped archive, so we need to extract it. So in Ubuntu, we can right-click and go to Open with Archive Manager. And then we can click on the folder and go to Extract. And it'll ask us what we want to extract. We can extract all the files. And go to Extract. Go back into my File Explorer, and you'll be able to see that there are a few different folders and files in this archive. You can open up this .txt file to read a little bit about the install procedure. Basically, there are kind of two steps. One is that we want to put this directory structure somewhere that we'll be able to find it later. So this is going to contain all of this, all these files that are needed to run CLion. You can really put this anywhere that you want. So I'm going to go ahead and copy all those CLion files into the directory usr/local. For this particular folder, I need to be administrator. So I'll need to use the sudo command. You could also do this through the file browser if you want. So cp-r download CLion, and then And I need to be sudo for this. Okay, and then I'm going to change into that directory. And then within here, there's a directory called bin. If I do an ls, you'll find that there are a bunch of files in there. The one that we want is called CLion.sh. It's just a shell script that runs CLion, so we can just run that kind of manually by doing / and then typing CLion.sh and an ampersand. And here it's going to open up CLion. Don't need to import any settings. All right, so now that we're in CLion, there are a couple of different ways that we could open up our Helios project. One is we could go and manually pull it from GitHub, and then we could go to this open here and then open up that directory from GitHub. CLion has a nice feature that we can just pull it directly from GitHub automatically. And so if I click on this get from VCS, which stands for version control, I can do that. So it's going to ask us for the URL of the Helios GitHub repository, and I'll type that in here. So it's https://www.github.com/plant simulation lab, uppercase to start each of those words, and then Helios. And then it's going to ask you the directory where you want to put it. By default, CLion creates this directory under your home directory called CLion projects. And so we can put it there. You could also change the name if you wanted. But then you can just hit clone. And we can trust the project. And there we have it. You should see the README file for Helios. On the left-hand side here is our project file browser window. This is the directory structure within Helios that was pulled from the GitHub repository. It's going to open up this project wizard that's going to help us set up our toolchain. Toolchain is basically the build tool as well as the compilers that we want to use. And we can just go ahead and click OK for now. We're going to come back to this here in a second. So one thing about running CLion on Linux is that you'll notice that if we close out of CLion here, this icon goes away. And then we basically, in order to start it again, we have to go into our terminal. We have to go find that directory and then launch that CLion.sh script every single time, which is kind of a pain. So we can go ahead and do this automatically within CLion. So let's open it back up again. If you're following along, you didn't need to close it out there. And so if we come up here to this tools, or the main menu, sorry, and then go to the tools menu, there's this item called create desktop entry. And this will basically create a CLion startup menu and other things that make it easy to launch it. So if we go ahead and click OK, let's try and exit CLion again. We should be able to find it under here, under applications. Type CLion. And here it is. You'll also notice that we can right click here and go to add to favorites, and then it'll be handy for us when we want to launch it again. All right, next let's go ahead and set up our compiler and build environment so that we can run some projects. So to do that, let's go up here to the main menu and then go to File and Settings. And we want to find the menu option for build, execution, and deployment, and then expand that. The first thing, let's click on toolchains. This is basically the screen that came up automatically when we opened our project. It just created this default toolchain for us. Main things to look for is that we're going to use the bundled CMake. That's the one that comes with CLion. And then it's going to say that it auto-detected our build tool, our compilers, etc. We just want to see that it has these green check marks and it detected to make sure that it found everything. And again, this goes back to our step previously where we installed the C and C++ compilers for our system. So next, let's go to the next menu item, CMake. And this is going to define our build environment. So you'll notice that our toolchain is default. That was created here. This corresponds to the name that we made up in this box here. We could name it something different if we wanted to. We just kept it with default. So the only option for our toolchains to use are default because that's the only one we created. The next one is the generator. This is basically the build tool. And this one is important. So by default, it's going to use Unix makefiles, but we always want to come down here and explicitly select Unix makefiles because CLion can sometimes switch back and forth if you just tell it to use default. So we want to explicitly select this Unix makefiles. The next thing is the build directory. So this is the folder where it's going to put the entire build. It's created a default name for us. Usually the convention in Helios is to just call it build, but you can call it whatever you want. This is just a name, so you could make up anything, but traditionally in Helios, we just call it build. One option that I skipped is the build type. So there are several different build types that are supported under Helios. One is the debug build type. So in this build type, it's going to disable any compiler optimizations, and it's going to enable debug flags. So this is useful when you're trying to track down errors and use the debug tool within CLion. You'll typically want to enable this option. There are some other ones. We also have release. So if we were to build with release, this is going to enable compiler optimization. So typically it's going to run quite a bit faster than in debug, maybe 3 or so times faster on Linux systems. It's also going to disable those debug flags. So it's going to be more difficult to debug and figure out what goes wrong if your program crashes. So you want to run this if you're doing production runs and you need that speed, but you're pretty sure that you've got all the bugs worked out. There's also this option called rel with deb info, which stands for release with debug info. So this is going to basically enable the compiler optimizations, but it's going to also enable the debug information. That sounds great because it's kind of the best of both worlds between debug and release, but this is usually not recommended because the reason why we disable optimizations for a debug build is because those can mess with the debug information. So sometimes line numbers can be wrong or other variables can be incorrect if you enable compiler optimizations because it can switch around the code within the compiler. So we generally recommend not to use this option. So let's go ahead and do a debug build. You can also add multiple builds here. So we could add another one and build both in debug and release if we wanted to. Let's go ahead and click OK here. All right, so now we're going to run the simplest test case within Helios, which is just running the context self-test routines. So this is going to just run through a number of automated checks within the context in order to make sure things are working appropriately. So if we go in our folder structure here to the left, we can expand this one called samples, and you'll find the folder called context_self-test. And if we expand that, we'll find that it contains 3 important files or directories. So it's going to contain this directory called build. It doesn't have anything in it currently because we haven't built yet, but you'll see here in a minute, once we build it, then it's going to put all of our build files and everything into that folder. So if we want to start over and do a build from scratch, all we have to do is delete that directory, and then it will delete the entire build and start completely from scratch. The next is this file called cmakelist.txt. This tells CMake how to build the project. I'll cover this in more detail in a future video. And then we have our main.cpp file. Basically, this is the main routine that is going to be run when we run our executable, and all it's doing is running the context self-test. So if we want to build this project, all we have to do is come to the cmakelist.txt file under context self-test, right click on it, and click on load CMake project. And so if we come down and click in the CMake window, it'll give us all of the output for this configuration. And it should get all the way to the bottom and give you this message called build files have been written to, and then the path to that build directory, and then finished at the bottom. And if we expand this build directory, you'll notice there's now a bunch of stuff in it that was due to that build. You'll also notice that these files have a little blue square next to them indicating that they're part of the current build. So that configured, now we need to compile and run. So some additional things changed. You'll notice up here we have information about our executable. So this context underscore self-test is the name of the executable. Where does that come from? That's defined inside of the cmakelist.txt file. So there's this line where you define what you want your executable to be called. We could have called it anything. Here it's just called context underscore self-test, and that's what corresponds to this item here. And you'll notice that it has a little play button and a debug icon. That's because this is an executable. These other things are targets that were created as part of the configuration, but these can't actually be run. These are just library targets. So we want to make sure that the executable is always the one that's selected. And then if we click this hammer button, that will compile it. If we hit the play button, that will compile and run it. So let's just go ahead and compile separately first, just to illustrate how that goes. It should bring you over to this messages and build window. It's going to run through and build all of the different files. And it should get all the way down to 100% and say build finished, indicating that it was built successfully. If it doesn't get there, then it means something was wrong, so you want to always pay attention to this. And now we should be able to hit the play button in order to actually run it. And so it went ahead and ran. It output this message, running context self-test passed. That just means that it ran successfully, and it finished with exit code 0. In general, if your program runs successfully, it should return an exit code of 0. So we were able to run the context self-test, a very simple test. We're going to run 2 other tests to verify that kind of everything within Helios is working properly. So we can collapse this tab for context self-test. The next test that we want to run is to test out the visualizer to make sure that graphics are working correctly. So to do that, we'll run this visualizer case. So that's just plain visualizer, not visualizer underscore self-test. So under visualizer, we'll find that we have the same 3 items, a build directory that's empty, a cmakelist.txt file. Let's go ahead and look at that. So our executable name here is going to be visualizer underscore chess. So we'll look for that here in a minute. And then we have our main.cpp file. This one's a little bit more involved because it's going to create this chess scene in our visualization. So if we want to load this project, all we have to do is right click on the cmakelist.txt file and then go to load CMake project just like we did before. And one important thing to notice here is that it didn't pick up the correct executable. So it found dist free type. This is not an executable. Again, we set our executable as visualizer underscore chess. We can also note that this has the play button and debug button next to it, indicating it's an executable. So we want to make sure that we select that one. And once we've selected that, we can build it. First, actually, let's check our CMake window to make sure that it all configured correctly. And indeed it did, and it wrote our configuration files here. So let's go ahead and build. All right, and we successfully made it to 100%. So let's go ahead and click our run button. And with any luck, we should get this visualizer window here with some chess pieces. We can go ahead and close that out. And we verify that it finished with exit code 0, meaning that it all ran successfully. All right, so let's run one more test in order to verify that our CUDA install is working correctly and we can run GPU-based programs. In order to do that, let's run this energy balance underscore self-test project or sample. So again, we just need to right-click on the cmakelist.txt file, click on this load CMake project. Can take a quick look at what our executable is going to be called. It's energy balance underscore self-test. So again, it didn't quite pick up the right one. We need to click on energy balance self-test, which is the executable. And let's check our CMake output real quick. One important thing that I want to direct your attention to is this line right here. So it should say that it found CUDA and then give you the version that it found. So you can verify that that worked correctly. If you get a bunch of big red text saying that there was an error related to CUDA, then you know that there's something with your install of CUDA that went wrong. So now let's go ahead and build. And it finished successfully, so let's run it. And it says running energy balance self-test passed and exit code 0. So everything went as planned with that run. So that's about it for CLion. It looks like we verified that everything is working correctly. So we can move on to the next example. All right, next we'll demonstrate how to do basically the same thing except using Visual Studio Code. So the first thing we'll do, of course, is to download and install VS Code. Then we'll use that to pull the Helios code directly from GitHub. Then you need to install the CMake tools add-in within VS Code, and then we'll configure and set up our VS Code CMake projects and run several different tests. All right, first thing to do is to go download the installer for Visual Studio Code. There are many different ways that you can install VS Code. We'll go right to their website and download the installer package. So I'll type in VS Code download, go to their website, and then we're running on Ubuntu here, so I'll download the .deb package. So we'll open up our terminal, we'll change into our downloads folder, which is where our installer went. And then we'll run this command here. And we want to run this as administrator. It's also possible to install this in your local profile without installing it at the system level. In that case, you could run it without sudo. You would do dpkg -x and then the .deb file, and then you need to specify a directory where you want to install it. So once it's finished installing, then we can go ahead and open up VS Code by just running the command code. And then if we do ampersand, it will run it in the background. So here we have it. We can configure or do different customization things if we want. With VS Code, I'll just accept all the defaults. Now the first thing that we want to do is to check out the Helios source code. So if you had already cloned it from GitHub somewhere on your local computer, you could go to Open Folder and then browse to where the Helios main repository is. Here, let's go ahead and demonstrate how to check out a fresh copy off of GitHub. So in order to do that, we'll press Control-Shift-P. This is kind of the magic key combination in VS Code that opens up this menu that allows you to type in different things that you might want to do. So let's type in Git, and then it will bring up a bunch of different Git options. Let's go to clone. And then it's going to ask us for the URL to a repository that we want to check out. So we can put in the URL to the Helios repository. So that is https://www.github.com/plant-simulation-lab with capital letters starting each of those words /Helios. And we want to click on clone from URL. If we click on clone from GitHub, it's going to ask you to link your GitHub repository and pull things directly from your own account. So we don't need to do that. We just want to clone directly from the URL. Next, it's going to ask us where we want to put it. So let's go ahead and maybe put it on the desktop. And it should pull from the Helios repository and create a directory called Helios on our desktop, since we said that's where we wanted to put it. And it'll ask us if we want to open it. Yes, let's go ahead and open it here. And we can go ahead and trust. So here we have in our Explorer the Helios source code. This is the main directory under Helios that's checked out from the repository. So the next thing that we need to do is to install CMake tools within VS Code, so we'll have access to those tools. So this little icon that looks like blocks, that's called extensions, go ahead and click on that. And then we'll search for CMake. And you should find here CMake tools. So click install there. Open up this window that'll tell you a little bit about CMake tools. And it is now finished. So it'll ask us if we want to configure our project Helios. Let's say no for now. We're going to do that here in a second. It's up to you if you want to configure projects on opening. I'm going to say no. We can close out of here and then go back to our main directory. So now what we want to do is to build and run a few different test cases. First thing that we're going to run is the context self-test. This is kind of the simplest test within the Helios samples. So all this does is runs the built-in tests within the context, which is sort of the central repository of Helios. So if you look under this directory called samples, there are a bunch of different samples here. The one that we're going to run is context_self-test. So within here, you've got three basic elements. One is this directory called build. It's empty for right now because we haven't built anything, but this is where we're going to build this project. Next, you have the CMake list.txt file. This tells CMake how to configure the project and how to compile everything. And then we have this main.cpp file. This contains our main routine that is going to be run here. And this is very simple. All it does is to run the self-test. Okay, so the first thing that we want to do is to specify or tell VS Code that we want to build this project in this directory here. And so to do that, we want to click on this little gear icon that's called Manage, and then go to Settings. And then under Extensions, you should find CMake Tools that we just installed. And then we want to scroll down to this part that says Build Directory. So this is going to tell us where we want our build to go. By default, it's just under workspace folder, which this is just going to be this main Helios directory /build. So by default, it would just create a new directory in this main Helios directory called build, and it would build it there. So we want to build under this project to kind of keep things separate. And so we're just going to change this a little bit. So I'm going to change this to samples /context self-test /build. So that's where we want to put it. We can go ahead and save this. What you'll notice here is you can also open up this settings file. So in VS Code, when you set some particular settings, it's usually just going to write it to a JSON file. And so you can find here that this is essentially where it put it. So that graphical interface is just basically going to write it to this JSON file. Okay, next thing that we want to do is to go ahead and configure our project. So if we hit the magical Control-Shift-P and then type in CMake and then go to configure. Now the first thing it's going to ask us for is our kit. This is similar to the toolkit in CLion if you watched that part of the video. This is more or less our compiler that we want to use to build this project. And I'm going to click on this one. So this is using just the basic GCC and G++ compilers that we installed. So I'm going to click on that one. Next, it's going to ask us what build variant we want. So we have several different build variants that we can use within Helios. The first one is debug. And as it says in this description, with debug, we disable optimizations and we include debug information. So this is going to give you things like line numbers when you are debugging if your code crashes. And so the reason that we disable optimizations is because when you have compiler optimizations, it can mess with that debug information. Sometimes it can give you the wrong function name, or it can give you the wrong line number or things like that. If we've already debugged our code and we're fairly confident that it's working correctly, then we would run in release build mode. So here it's going to enable compiler optimizations. So on Linux, it's going to typically be about 3 times faster. And it's not going to include any debug information. So if your code does crash, then it may be much more difficult to figure out what's going on because it won't record a lot of that debug information. And then the third one that you can do within Helios is this rel with deb info. This stands for release with debug info. And this basically enables those compiler optimizations and also builds with debug information. So you might be thinking that that's perfect, that's the best of both worlds. But as I mentioned before, if we enable those compiler optimizations, then it can sometimes give us incorrect information when if our code crashes. So we're going to go with debug here. The next thing it's going to ask us for is the path to a cmakelist.txt file for the project that we want to run. And as I mentioned, we're going to run the project in samples/context self-test. And as we said before, there is a cmakelist.txt file in there, so we just need to find it. So here it is, context self-test /cmakelist.txt. So there's a bit of a bug in VS Code, and I'm not quite sure why it does this, but it automatically tries to run ctest within CMake when you build a project for the first time. And the only way that I found to get around this is fairly simple, but if you just close out of Visual Studio when it gives this ctest error, and then just reopen Visual Studio Code, it should make that go away. So if we just reconfigure, then it should work after restarting VS Code. And if we look down at our output, we should find that we get all the way to the end and we get this message called build files have been written to, and then the path to our build directory. So that indicates that the configuration worked correctly. So the next step that we need to do is to go ahead and compile so that we can run it. And in order to do that, we need to tell it which target it should run. And so if we come to this bottom toolbar here, it will allow you to specify the build target. So if you click on that, it will show you a drop down of all the different targets that are part of the CMake project. Many of these are libraries that are built as part of the configuration and build process. And the one that we want to select is the executable. So for this particular project, context_self-test is our actual executable, and it is denoted by an executable keyword. And so we want to go ahead and click on that. So then it should have it selected down here as the default build target. And we could click build if we just want to compile, or if we hit the play button, it should compile and run. So just to show these kind of separately, we'll compile it separately first. And so it should make it to 100% and say build finished with exit code 0. So that means that it was successful. So now we can go ahead and run it. And we want to make sure that we have context self-test selected here as our build and launch target. And then we'll go ahead and launch, which just means to run it. And so it should say running context self-test and then passed. So that means that it ran all of the self-tests in the executable, and then passed means that it passed all of them. So that means that it ran correctly. So we verified that we're able to run kind of the simplest test case within Helios, just the context. We haven't run any plugins or anything. And so next, let's go ahead and verify that we can do visualizations. This is a bit separate and requires some extra libraries from just running the context. So we'll want to test to make sure all of those were set up correctly based on the steps that we did before to install those libraries. So in order to change projects in Visual Studio Code, there are two different things that we have to do. If you watched the CLion part of the video, you know that it was very easy to switch projects. You just had to right click on this CMake and then load it, and that was it. Here we have to change two different things. One is we need to change our build directory again to our new project, and then we need to specify our source directory that contains the CMake list.txt file that it's going to run. So since we already have this one up, this one is from the settings. So again, to get to this one, if you don't have it already up, then you go to this gear icon and then click on settings, and then go to extensions. And then you can browse down here to where the build part is, or click this little button that will open up this JSON file. And so we want to change this from context self-test to visualizer. So we're going to go ahead and run this project called visualizer, not visualizer_self-test, but just visualizer. And we're going to run this one. So again, this contains an empty build directory. It contains a CMake list.txt file for this project, and then a main.cpp file. So let's just open up this CMake list real quick. So just as a heads up, we're going to find that our executable name for this project is visualizer_chess. So we'll look for that when we're selecting our build and run target here in a second. Okay, so we changed our build directory. Now we need to change the source directory, which is going to point to this file here. And so that one again is under this VS Code hidden directory that was created And then this is going to allow us to change our source directory. So we want to change this to sample/visualizer. And then we'll go ahead and save that one. It looks like I forgot to save this one, so we'll Control S on that. And then what we want to do is to reconfigure, so press Control Shift P, and then find delete cache and reconfigure. If this is not showing up at the very top of your list, just start typing CMake and then find it. Okay, so it says our build files have been written. Another thing that we need to do is we need to change this build and run target. So it's still set as context self-test, but we're not running that project anymore. So we want to again find the executable. And you'll notice that there are some other executables that could be run related to the libraries, but we want to find the one visualizer_chess because that's the name of the executable for the actual project. And again, we saw that in the cmakelist.txt file. So we'll click on that one as our executable. Let's see if this is available yet. Yeah, we'll click on this one, visualizer_chess as our run target. Try building again. Okay, and we should get down to 100% and this build finished with exit code 0. If you have an error with that, I would double check that you changed both of these correctly, both of these settings.json files correctly. Make sure that your build and launch target are both visualizer_chess. And then at that point, you should be able to hit the play button. And with any luck, it'll open up a graphics window here with a chess piece and a chessboard. This is just a sample visualization, but this indicates that the visualizer is working correctly. So you can go ahead and close that. And we've shown that we can also run the visualizer. The last thing that we want to test is to make sure we're able to run GPU-based programs. This will verify that our CUDA was installed correctly. And so for that, we're going to run the energy balance self-test. So this uses the GPU. This will allow us to verify that. So if we expand this, we again have a blank build directory. We have a cmakelist.txt file and a main.cpp file. If we open up our CMake lists, our executable name is going to be energy balance _ self-test. So we'll look for that here in a minute. Close that up. So we'll go through the same couple of steps. So we need to change our build directory, and we're going to change that to sample/energy balance self-test /build. And I'll remember to save that this time. Then we go to this one to set our source directory. So sample/energy balance _ self-test. Make sure and save that, Control S. Okay, now we should be able to reconfigure. So we'll do Control Shift P, delete cache and reconfigure. And it should say build files have been written to, and then our energy balance self-test. So let's make sure and choose the right target, which again is going to be energy balance _ self-test executable. Then we can choose our build target here. Automatically selected it because that's the only one available for this particular project. So then we can try building, and it should get to 100% again. Build finished with exit code 0. Then we can hit the play button to launch it. And it should say running energy balance self-test and then passed, indicating that it ran successfully. And that's it for now. We've verified that we can run the basic components of Helios within our VS Code. All right, and finally, we're going to show how to install and run Helios just from the Linux command line. And if you're watching this video, you're a Windows person, but you're using Windows subsystem for Linux, then it should follow the same methodology. So we're going to clone Helios source from GitHub from the command line using git. Then we're going to configure with CMake and then compile with make and then run our executable. Okay, first thing is that we're going to clone the Helios source code using git. If you don't already have Git installed, then you can do sudo apt-get install Git, but we have it here. So we want to use the command git and then clone, and then the URL to the Helios GitHub repository. And that is https://www.github.com/plant-simulation-lab with all capitals, starting each of those words, and then Helios. So if I was to just hit enter here, it would clone it into a directory called Helios. But since we're on the desktop, and when we were installing VS Code, we also cloned Helios into the desktop, I'm going to give it a different name. So I'm going to call it Helios-clone here just to separate it. And so it's going to clone it into a folder called Helios clone here on the desktop, or whatever directory that I'm in currently. All right, so now you can see that it popped up on the lower right hand of the desktop. So we can change into that directory. And if we ls, then we can see all the directories and files that come with the base Helios repo. And so what we want to do is to run through a few different tests in order to verify that our install is working and that we're able to run things from the command line. And so there are a number of different sample cases in this directory samples. And the first one that we're going to run is the context self-test. This is pretty much the simplest case here. All it does is run the test routines for the context, which is kind of the central repository of Helios. So I can change into that directory. And in this directory, you'll find three main things. The first is a cmakelist.txt file. This tells CMake how to configure and compile the project. The second is a directory called build. So this is where we are going to build our files into. Everything gets compartmentalized into there. So if you want to start over with a fresh build, all you need to do is clear out that folder and it'll start fresh again. And then we have this file main.cpp, which is the main routine that has what is going to be run. So I can open that up. I'm just going to use Nano, but you can use whatever text editor that you like. So it's just a very simple main routine that runs the self-test. And let's take a look in this CMake list file. And the thing that I want to point out is that there's this line where you define this variable executable name, and this is going to be the name of the executable that's going to be generated, which we're going to run here in a second after we configure our project. So we're going to change into that build directory. And the first thing that we want to do is to configure. So we'll do cmake and then ... This is basically referencing the path to that cmakelist.txt file, so it knows where to find it. There's one argument that you may want to specify here, and that's the build type or the build variant. And there are three different build variants that you can use with Helios. The first one is debug. So this is going to disable all compiler optimizations, and it's going to generate a bunch of debug information so that if your program crashes, then there's information to debug that. It'll sometimes spit out line numbers directly in the error message, or you can use something like GDB in order to debug your program. The reason that we disable compiler optimizations for debug is that when you have compiler optimizations, it can do weird things with the debug information and make it incorrect. Sometimes there are incorrect symbols, sometimes incorrect line numbers, etc. The next build variant is called release. And this basically enables compiler optimizations. So it's usually going to be about 3 times faster on Linux when you're running under release. And it's going to not generate any of that debug information. So if your program does die when you're running release, then it will be much more difficult to figure out what's going on. Then there's a third variant called rel with deb info, and this stands for release with debug info. This basically enables compiler optimizations and also enables debug information. So you might be thinking, this is the best of both worlds. It's not only fast, but it generates all my debug information. But this is usually not recommended for the reasons that I mentioned before, which is that it can mess with the debug information and make it incorrect. So how do we specify the build variant? So there's an argument -d, and then we type cmake _build_type, and then equal, and then the build variant that we want to use. So it could be debug, it could be release, or it could be rel with deb info. And so we're going to build with debug. If I was to not specify anything, if I was to only type cmake ... it would use debug by default. So if you want to do debug, then you don't actually need to type all of this out. So I type enter, and it goes through and configures. There may be some warnings related to the cmake version, but that's fine. We don't have to worry about that. We want it to get to the end and get to build files have been written to, and then the directory indicating that it made it all the way to the end. So now you'll see that it generated a bunch of cmake files, including one called makefile. So we use make in order to actually compile. So the cmake step was for configuration. Now if we type make, it will actually compile. And once we get to 100%, that indicates that it is finished and everything went correctly. So if we do an ls again, we should find this executable file called context_selftest. Again, that was specified in our cmakelist.txt file. So that's where that name came from. And then we can go ahead and run it. In order to run an executable, you have to do // in order to tell it to run that specific file, not some command that's in the path somewhere. So we do // and then context self-test, hit enter, and it should say running context self-test and then passed, indicating that it passed all of the tests. Okay, the next test that we want to run is for the visualizer to make sure that graphics are working correctly. So if we change back into that samples folder, then we should find a sample called visualizer. So not visualizer self-test, but just plain visualizer. So let's change into there. And I just want to take note of that cmakelist.txt file that's in here. So let's view that. And here our executable name is going to be visualizer_chess. So that's what's going to be created once we compile. Okay, so let's change into that build directory. And we'll do cmake. And I'm not going to put the build type. We're just going to build in debug mode, which is again the default. Built our files, so we can type make. And again, it should get all the way to the end to 100%. Let's just take a look. We've got this executable called visualizer chess. So we can run that just like we did before. And it should open up this window of this chess scene indicating that it worked correctly. If it doesn't, if it gives you some errors when it tries to open up the window, then go back to the step where we installed the dependencies for the visualizer to make sure that you installed all of those correctly. Okay, and the final test we want to look at is to verify that our CUDA and GPU-based plugins can run correctly. So we'll go back to our samples directory. And we'll notice there's one called energy balance _self-test. We're going to run that because it uses CUDA and the GPU plugins. So we'll change into that one. Again, we have our usual files and directories in here. Let's just take a look at that CMake just to see what our executable is going to be. It's going to be called energy balance _ self-test. So let's go into our build directory and CMake. Build files were written, make to compile, and we got to 100%, so we can run it. Again, it was called energy balance self-test, and it should say passed, indicating that it ran correctly. So there we have it. That's how we run different programs in Helios just from the command line.